Welcome everyone to our webinar, Livestock Methane, Identifying Gaps to Advance Meaningful Solutions. The intent of this webinar is to catalyze debate and cross-learning from different points of view. I'm Shefali Sharma, Director of the Institute of Agriculture and Trade Policy's European Office. I'll be moderating today. A little bit about IATP. We were founded in 1986. We work to create just food and agricultural systems, working locally and globally at the intersection of policy and practice. A few quick housekeeping notes before we get started. I'd like to draw your attention to the Zoom webinar control panel at the bottom. Please ask questions of our presenters at any time by typing your question into the Q&A box located within the panel and selecting the send button. We will get to as many questions as time allows during our Q&A period at the end of the webinar. Please note that we will not scan the Zoom chat for questions, so if you'd like your question addressed, please use the Q&A function. Also, this webinar is being recorded and will be available on IATP's website. We will send the link to attendees and registrants within the week. So welcome. Methane is a short-lived greenhouse gas, but 80 times more potent than CO2 in the atmosphere. Scientists now confirm that drastically cutting methane this decade would buy humanity time to give us a chance to limit warming to 1.5 C. Livestock contribute 32% of all methane emissions, and though 150 governments have signed the Global Methane Pledge, very few have concrete plans to address livestock methane emissions, particularly from the factory farm model of producing beef, dairy, and pork that originated in the US, and which is now being adopted around the world. Policy discourse around agricultural methane also centers heavily on technological innovation and further intensification. We urgently need a more meaningful discussion about solutions to livestock's methane problem that can protect human rights and food security and sovereignty, promote biodiversity and adaptation. The US experience with the factory farm system has resulted in major water and air pollution in rural communities, the loss of small and mid-sized farmers, poor working conditions, and increased food safety risks. The Biden administration's methane plan, for instance, leaves this factory farm system intact and in fact further incentivizes its expansion by proposing to expand the use of methane digesters and research new feed additives for cattle within this system. Yet our livestock methane solutions shouldn't ignore significant harms caused by factory farm systems. There is increasing pressure on countries and companies to reduce their methane emissions. How does adopting intensive livestock systems developed in the global north benefit the global south? Sub-Saharan Africa? What are the trade-offs and impacts of path dependencies on such systems? Will these systems reduce methane emissions? What are other impacts of such systems? What kind of solutions for livestock are needed to address agricultural systems in Sub-Saharan Africa that both reduce methane and bring other critically needed benefits to livelihoods, climate resilience, adaptation, and biodiversity? We bring together an amazing set of speakers and panelists to address these gaps in the current discourse on livestock methane, with the hope that the discussion leads to more meaningful engagement on holistic and equitable solutions regarding livestock methane. So it's my pleasure to introduce Ian Scoones. Ian is a professor at the Institute of Development Studies at the University of Sussex, an ecologist by original training. He works on issues of agricultural and environmental change, particularly in Africa. He's the principal investigator of the ERC Advanced Grant Project, Pastors, Pastoralism, Uncertainty, and Resilience, Lessons from the Margins. Over to you, Ian. Thank you.
Thank you very much. So let me share my screen. So in this talk, I want to think a little bit more, in a little bit more detail about the relationship between livestock, methane, and climate justice. Now, I know this is not a common focus because these tend to be rather technical debates, but I want to convince you that it's important if we want to address a just transition in the face of climate change. First, some starting points. Shefali has covered some of these, but it's worth re-emphasizing. Methane is a really important climate forcing gas. Reducing it is absolutely imperative, although overall, carbon dioxide is more important in the long term. Anthropogenic methane emissions come from agriculture, for sure, but also from fossil fuels and waste. Fossil fuel and waste emissions together add up to about 1.5 times the agricultural emissions, which are mostly from livestock. So yes, ruminant livestock produce methane. No question about that. And it's estimated to amount to 120 to 140 million tons per year. But there are also some important questions here. Which livestock, where, and where should global policy efforts focus? These are just more complex questions, which both raise important issues around justice, and that's the focus of my talk. So my reflections emerge from an ongoing project called Pastres, which Shefali introduced, which is working in 6 countries across the world. And it starts from an understanding of pastoral systems, extensive livestock systems on the ground in different contexts. And during the project, we become increasingly concerned about the way the debate about climate and livestock and methane is going. So first, a little bit of history. In 1991, there was an important report produced by CSE in Delhi by Anil Agarwal and Sunita Narayan, and it was a reaction to WRI's report on aggregate emissions at that time. It argues that it matters where emissions come from, and they made the important distinction between what they called survival and luxury emissions. Now, this is a theme that I picked up on in several papers with colleagues on livestock and climate, making the case that we need to differentiate between different livestock systems, not lump everything together in a simple aggregate narrative that all livestock are bad for the planet. So in sum, it's a debate about justice, but what do we mean by justice? I want to introduce 3 types of justice: epistemic justice, whose knowledge counts; distributional justice, who wins and who loses; procedural justice, who gets included and excluded. And I want to argue that all 3 of these are absolutely crucial when we're discussing livestock and methane, but are often missed. The problem is that the current debate just doesn't address questions of justice. There are big sweeping statements we see all the time based on global aggregate modeling that just offer far too little nuance. There are equally many voices missing from these debates, notably small-scale livestock producers and pastoralists. With methane emissions rising up the agenda, correctly so, and with countries signing up to the Global Methane Pledge, which was already mentioned, fingers of blame are pointed. The industrial producers say, yeah, we can fix all this through technology, feed additives, drugs, vaccines, even masks for cattle, without changing the system. And meanwhile, extensive livestock producers, who are usually not at the table, are seen as the real villain, blamed by the industry folk and environmentalists alike, in a sort of weird convergence of narratives on this issue. So let's dig into the debate a little further. How are these arguments constructed? On the basis of what data and what type of analyses? I want to suggest that the current approach creates serious epistemic injustices as certain views and certain types of data are excluded. Much of this, of course, arises inadvertently. The way the big figures, the classic 14.5% of anthropogenic emissions coming from livestock, are derived from what are called life cycle analysis. All the emissions are calculated across the value chain. But where does the data that go into these analyses come from? First, most of it is derived from well-documented commercial industrial farms. For example, one very frequently quoted paper published in the journal Science looked at many different farms and a number of different processes, but only focused on what they called commercially viable units, mostly from Europe and North America. Yet when these results are aggregated and shared, this is assumed to be the full story. These figures are then used by the media, campaign groups, data compilation sites like Our World in Data, as if the results apply to all livestock everywhere. The result is often false equivalence being made. Cows are as bad as cars, or cows are as bad as even coal. And I think this really distorts the debate. What then do we have to look out for when we see these figures? How should we nuance the livestock and methane debate? And I want to mention 4 different elements. First is the whole question of global warming potential measures, how to deal with different greenhouse gases in aggregate emission statements or CO2 equivalents. Without getting into the technical details, it all depends on how you treat time and the permanence of different gases, flows and pulses within the atmosphere. Methane is significant in the short term, but it decays over 12 years or so. Carbon dioxide, by contrast, sticks around. So what GWP measure you use makes a massive difference to the final figure. The graph shows two measures for livestock in Austria, quite a big difference, as you can see. This is not saying that methane is not important, it surely is, but different priorities exist depending on your policy objective and your time preference. Second is the measure of methane emissions you actually use, the emissions intensity. Most data that are used, say for the IPCC reports, come from well-bred animals in the global north, fed in respiration chambers. But if you actually measure livestock emissions in situ in Africa, as ILRI have done in Kenya, then the data is very different, perhaps 15% or more lower than these figures that are widely used. This is because such animals are physiologically and genetically different. They feed in particular ways, perhaps even browsing methane-reducing tannins, and so emissions are lower. Third is how emissions are measured in relation to the wider system. So are we interested in emissions per animal, per area, or per system? Looking at a system, as Sirad have done in Senegal, then we get a very different picture. Distribution of manure, incorporation of dry matter, and methanogenesis emissions have to be looked at all together. Some system studies suggest that extensive livestock systems, particularly mobile ones, can be net negative or at least in balance. Very different to an intensive, concentrated, fixed, contained system of industrial livestock. And finally, there is the question of additionality and the issue of baselines that are used. Work by Pablo Manzano and colleagues has compared emissions in a natural wild system, an extensive system, and an intensive livestock systems. And extensive systems, he finds, are not hugely different to a system dominated by wild herbivores, and therefore, in that sense, are not additional. For intensive systems, it's of course a very different story. So how and what you measure makes a massive difference. Each of these four elements have resulted in major biases in aggregate models that act against extensive livestock systems. This is what I call epistemic injustice. This matters as if we're to address emissions, which we must, then we have to decide how to do this and where. Should our policy efforts be focused on the sort of pastoralists we work with in our study sites, as in these pictures, or on industrial livestock systems, or maybe even on quick wins, such as sealing leaks in gas pipelines? For example, emissions from gas infrastructure in Turkmenistan last year was reported to be more than the total emissions from the whole of the UK across all sectors, and certainly much more than all extensive livestock producers in the rangelands across the world. Extensive small-scale livestock producers live in marginal areas, often marginalized economically and politically, and in the extensive rangelands where they live, which make up half the world's land surface, so they're important, there are often very few alternative livelihoods. Yes, they contribute to emissions, but at a low level with limited or even no additionality. So should such people be demonized and targeted for our global efforts to address climate change, or should our efforts be focused elsewhere? So if we're to address questions of distributional justice, we urgently need to differentiate, once again highlighting the difference between survival and luxury emissions. And this means refining the debate and the processes by which decisions are made within international climate policy. In our policy discussions on climate issues, let's avoid the aggregate statistics and the simplistic headline figures. In the processes of reporting nationally determined contributions to emissions, let's not just use the aggregate data and unrealistic emission factors. In the monitoring and verification processes around methane, let's differentiate between systems, between luxury and survival emissions. And in the discussions about livestock and climate in policy, let's involve those who know about local conditions and production systems. Researchers, yes, but pastoralists especially. At COP26 in Glasgow, I attended a meeting convened by a very well-known environmental organization on methane and livestock, and was shocked to find it totally dominated by those selling proprietary technologies for reducing methane in industrial livestock. No mention of extensive small-scale systems at all. This then is a question of procedural justice, of differentiation and of inclusion. Who is at the table and whose voices count? So in sum, this means when discussing methane and livestock, it means thinking about justice. Because epistemic, distributional, and procedural injustices are rife in this debate currently and are being made worse by inadequate science, vested industrial interests, simplistic environmentalism, shoddy media reporting, and biased international climate policy processes. If the rights of small-scale, extensive livestock producers are to be protected and a just climate transition is to be achieved, this, I think, needs to change. And that's a link to some of our work. So thank you very much. I'll stop sharing now.
Thank you so much, Ian. You were right on target, 12 minutes. I think it's a very interesting concept, luxury versus survival emissions. Now it's my pleasure to introduce Daniel Mulat, who is an environmental researcher and lab manager at the Mazingira Center, an environmental research and educational center affiliated with the International Livestock Research Institute, ILRI, in Nairobi, Kenya. The center was established in 2014 and is staffed by scientists and technicians from ILRI. The center promises a step change in Africa's environmental research infrastructure and capacity with a mandate to provide environmental baseline data and intervention testing and to serve as a hub for capacity building and scientific exchange. Daniel's primary area of focus is the measurement of greenhouse gas emissions and the development of biotechnological processes for converting organic resources, particularly livestock manure, into biochemicals, biofertilizers, and bioenergy, all within the framework of a circular economy. Daniel, over to you. You have 12 minutes. Thanks.
Thank you very much. Can you hear me?
Yep, we can hear you.
Right. Yeah. Hello, everyone. Today I'm going to present about methane emission in sub-Saharan Africa. I would like to talk a bit about scientific gaps, unique consideration for livestock adaptation and mitigation in sub-Saharan Africa. My name is Daniel Mulat. I'm environmental scientist at Land Managers Mazingira, and I would like to thank Ariane, the senior scientist and lead of the Mazingira Center, for contributing to this presentation. I think the screen is not moving. Okay, yeah. So a little bit background about Mazingira Center. It's an environmental research institute at International Livestock Research Institute to test and develop management strategies to increase livestock productivity while reducing greenhouse gas emission and improving resource utilization and reducing environmental degradation. As you can see on this picture, there is a growth in population in Africa. So in 2030, it's expected population to grow by 56%, in 2050 by 135%. So that means with a growth in population, there is expected growth in the demand for red meat and milk protein. So as you can see, it increased by 84% to 2030, and then by 207% in 2050. So that means definitely we'll be expecting more meat and milk is eaten in Africa. And of course, that can that's very important for the food system. And also it's important to look at what is a consequence on greenhouse gas emission from livestock system. So in Africa, we broadly define two livestock systems, the smallholder systems, where you can find in the humid and subhumid areas with very low land size and a small number of livestock. And milk yield also very low, around 4 liters per day, which is very, very different from the global north. And then the other system is a pastoralist and agro-pastoralist systems, which you can find in the semi-arid and arid areas. This is a vast area with multi-species livestock systems, mainly dominated by cattle and also small ruminant, and there are also some camels. And milk productivity is much lower than the smallholder system, which is less than 2 liters per day. So it's very, very important to look at what kind of livestock system we're talking about in Africa. And as a part of the African government commitment for international climate discussion, they have pledged for reducing greenhouse gas emissions and also on climate mitigation within the NDCs. And as you can see from this map, 10 countries included mitigation and adaptation measures. Only 5 countries included livestock mitigation measures. And 14 countries, which is in dark blue, they have included adaptation measures. 9 countries included no livestock measures, and 10 countries included no new or updated NDCs. So as you can see from this map, it's very clear that both adaptation and mitigation are important for sub-Saharan African countries. So among this mitigation and adaptation practices, so with regard to mitigation, the feed management is prioritized by most of African countries, and also manure management. There are also like breed management, herd composition, silvopasture, animal health, also included as mitigation practices. But with regard to adaptation, most of it is a feed management, breed management, silvopastoralism, and animal health. So there are a range of practices which are identified by the African countries for climate mitigation and adaptation. With regard to livestock adaptation, as you can see, this blue color shows that the countries which have included adaptation in their NDCs. But we don't really have currently a tracking system or a methodology to track livestock adaptation in Africa. There have been some development. Hopefully that will be available very soon. So without any adaptation tracking system, it would be difficult to set the target and also to continuously monitor the outcome of adaptation practices. With regard to greenhouse gas mitigation, as you can see, those which are marked in yellow are the ones who have included mitigation in their NDCs. There are only a few African countries. And among these, only a few of them are using the Tier 2 inventory methodology. So the Tier 2 is relatively better in terms of accuracy and representing the livestock system compared to the Tier 1 default values. So that clearly showed that we really have to move into Tier 2 or even higher methodologies for tracking the greenhouse gas mitigation of livestock system in sub-Saharan African countries. So at Mazingira, we have done some literature review to look at what are the data coming from sub-Saharan African countries in terms of enteric methane emission, greenhouse gas emission from manure, and then mitigation practices in the livestock systems. So as you can see, there are only few data coming from the livestock system in sub-Saharan Africa, which makes it very difficult to set a mitigation and adaptation target, and also for monitoring the outcome of those practices. And this map shows that there are only few laboratory facilities for measuring enteric methane emission from the livestock system in Africa. As you can see, most of the equipment are in Kenya, which is our center, Mazingira. And then in South Africa, there are some few in Tanzania, Burkina Faso, and Benin. So that clearly showed that there is definitely a research infrastructure gap for understanding the climate mitigation and adaptation in sub-Saharan Africa country. Although these equipments are available, because of the lack of funding, most of the equipment has not been utilized for measuring enteric methane emission, which means that the data we currently have from livestock system in Africa is mostly derived from the global north, which won't reflect the livestock system, the feed, and the breed available in Africa. We recently did some surveys to understand the emission factor for the livestock system in Ethiopia. So we looked at 3 different methodologies. The IPCC Tier 2, the CSIRO Tier 2, and then the IPCC Tier 1 emission, the default emission factor. And as you can see here, we have different categories of animals, as clearly showed that the emission factor for different methodologies are quite different. So that clearly showed that we really need more local data for the African system to better design the mitigations and adaptation interventions in sub-Saharan Africa. And then we also compared the IPCC Tier 2 methodology with emission we directly measure from the animals in Africa. As you can see that the prediction equation for the one which we directly measure from animals at early, and the one from the IPCC guideline, they are completely different. So it's very, very important to generate local data to inform the greenhouse gas emissions in African system. So that can clearly show that funding for equipment and capacity building are very low in sub-Saharan Africans. So we really need more funding to generate local data, robust data, which inform practices and policies for the livestock system in Africa. We also think collaboration between south to south, which is what we're trying to do at Mazingira, for example, where we train researchers, government officials in Africa to generate better data on the system. And also we collaborate with Global North for the livestock system. And here you can see climate smart agriculture practices is promised for increasing productivity, adaptation and resilience to climate change and reduce greenhouse gas emissions. But we're currently lacking data, the implementation of this, whether they have been living up to their promises. So we recently have done some surveys for the Kenyan Climate Smart Agricultural Project, which was implemented by Kenyan government with financial support from World Bank. So they have introduced different climate smart agricultural practices, as you can see here. And what we found from the survey is that when you do have a different system, the extensive is when animals do grazing at least 70%, and no grazing 70% of no grazing, and the semi-intensive is a system in between. As you can see, the milk yield is higher in a no grazing system. It's low in the extensive system. But when we looked at the milk yield in each systems, as you can see, the error bar is very high. So that means there is an opportunity to improve the milk yield within each system without even moving from extensive to no grazing system. And then as you can see, the emission intensity also higher in a no grazing system, but that doesn't mean that the total emission is lower on a no grazing system. And then we have looked at adoption of these different practices, whether it reduces milk and whether it increases milk yield. As you can see, for the farmers who adopted more climate smart practices, for example, here, when they adopted more than 5, and then the milk yield has increased, and then the emission intensity, the emission per product, per milk, also reduced. So that means the more climate smart agricultural practices are adopted, the higher milk yields and then greenhouse gas emission intensity reduction. Then we also looked at the costs of associated in implementing these practices. So as you can see, when you have more practices and the costs for producing milk is higher, respective of the livestock systems. But when we included additional income from the additional milk produced, as you can see on the picture here, which is negative, which means that the net income when you adopted these practices is higher for the whole, for every extensive system, but it's only higher when the farmers adopted more than 5 practices for the semi-intensive and then no grazing system. So that clearly showed that in terms of net income for extensive system is much better, but then the upfront investment will be higher, which might discourage farmers to adopt these practices. And then the other case study I want to present is the African biogas component, which is...
Daniel, you have 1 more minute.
All right, okay. So this is the idea is to use manure for producing biogas as a clean energy source and bioslurry as a fertilizer. So this project is aimed to improve the biogas sector in selected sub-Saharan African countries to reduce greenhouse gas emissions and then to providing clean energy biofertilizer. Hopefully, some of the data from this project will be available next year. And then takeaways from this presentation is the current capabilities for monitoring, mitigation, and adaptation fall short of the NDC's goals. Funding allocation for equipment and for capacity building are inadequate in the sub-Saharan Africa. And development of local equations which can cater for the local system is very, very important to generate accurate data and inform policies and practices in the livestock system in Africa. And we, as I have shown from the KSAP project, optimizing production system can lead to substantial benefit. One of the challenges is upfront costs. So it's very important to have a financing mechanism to lower barriers for adoption of these practices. And we also think that there is a need to collaborate with national and international key partners in Africa and global nodes. With that, thank you very much for listening.
Thank you, Daniel. Unfortunately, we were due to have Matthew Hayek speak, but he's unable to make it today. So we lose an important perspective on the panel, but we hope this is one of many conversations that we will have about meaningful solutions to the livestock methane problem. You can find his work at a link that my colleagues are just going to post in the chat. So now I want to open up the the discussion to our panelists who will respond to some of what they've heard, but also I will also pose a question to you. And each of you have 7 minutes to respond. So let me first introduce Monicah Yator. She's the founder of the Indigenous Women and Girls Initiative, a community-based organization in Baringo County, Kenya. She's a human rights defender, feminist, and activist with 13 years experience in community development. Yator comes from a pastoralist community where livestock is a way of life. She works with women and girls to develop alternative livelihoods through agroecological practices to build communities' resilience and adaptation to climate change impacts. She's a member of the Agroecology Coalition, East and Southern Africa Pastoralists Network, and member of the Pastoralist Alliance for Resilience in Northern Rangelands. Thank you so much, Monicah, for being here. During COP27, the Green Climate Fund approved a project preparation process for a joint project between IFAD, FAO, and the Global Dairy Platform. The Global Dairy Platform includes some of the largest dairy companies in the world, such as Fonterra, Arla, Friesland Campina, and others. The aim of this project is to reduce farm-level methane emissions intensity and the whole set of value chain emissions from farm to fork in dairy supply chains in Kenya, Rwanda, Tanzania, and Uganda. What is your response to this, and what do you think is most important to support in terms of climate and methane for livestock in your region? Monicah, over to you.
Thank you so much. And I would say I'm proud pastoralist and abundant pastoralism. And to me, I think from the discussion we're having now, from a pastoralist perspective, it is impossible. So because we don't have data, we have not been informed how many gas emissions pastoralists meet. So first question is how many and when did this data done? And of course, looking at the pastoralists in Kenya and East Africa, they have a small, maybe few livestock herds, and these few livestock herds depends on grasslands. And this is our livelihood. And nobody is giving us alternatives. Even at COP27, we were talking about that emission, mitigation, and adaptation. I'm even shocked to see my president talking about mitigation. Nobody's talking about adaptation. And pastoralist livestock is our adaptation livelihood. And if you tell us we are emitting so much gas, at what percentage? So my question is, at what percentage? And I pose that question to Mullah as well. So to help us unpack and even negotiate further for pastors and livelihood, being a mother and being a woman from the pastors community, our livestock is our 100% livelihood. And of course, we are feeling the impact of climate change. We've lost a lot of livestock. At the moment, our parents are still in shock on how to build back. And of course, how do we bring back our livelihoods? And you cannot tell us to start planting trees. You cannot plant trees where there is no rain, but we can adapt to climate change. But then, who are emitting that? Yes, we have cows, which can even give you half a liter of milk. We have to depend on meat. We have to depend on herbs to survive as a pastoralist. But again, where are we in this conversation? As we focus in the upcoming COP28, we are still seeing missing gaps. Everybody's thinking about that emission. Everybody's thinking about carbon trading. Everybody's talking about emitting and reducing this gas. And how? My question again is, how do we involve pastors and pastoralism? Yes, we have alternatives. And that's why the organization and others are bringing alternatives. We are now integrating small-scale agriculture. But then we are even doing water harvesting, of course, to build back resilience. But again, how best can this conversation build into the funding that is coming in with climate resilience? Nobody's speaking about it. So again, I will pose again this question to all of you, all researchers. How do we bring in indigenous knowledge in carbon emission? How do we build up? How do we integrate our indigenous knowledge in this climate change mitigation? Because of course we used to have our own way of adapting to climate change, and of course mitigating that. How do we bring in back our indigenous knowledge in this discussion? And of course, here we can still engage and talk more. And I will say pastoralism is here to stay. It is our livelihood. It is our way of life, and we have to build it better. And also link research and indigenous knowledge in this. Thank you.
Thank you, Monicah. I think several people were not able to hear properly. I wonder if you could maybe put some of your comments in writing as well, so that we could share it with the participants after. That be possible?
Okay. Sorry about that.
Yeah, no worries. I mean, we could hear, but I think there were times when it was a little bit. Thank you so much. Now I would like to introduce Maina. She is the National Coordinator of the Biodiversity and Biosafety Association of Kenya, BIBA Kenya, a member of the African Food Sovereignty Alliance, AFSA. With over 15 years experience as a development practitioner, Anne has been actively working with communities and challenging false agricultural solutions being pushed in Africa. She's contributed to the growth and development of various regional networks in Africa, including the Eastern and Southern Africa Small Scale Farmers Forum, SF, Participatory Ecological Land Use Management, Pelham Association, and AFSA. It's the same question to you, Anne. What's your response to intensification of livestock in Eastern Africa, and what do you think is most needed to support mixed farming systems that include livestock in your region with regards to climate and methane?
Thank you very much, Shefali, and thank you to Dr. Mulat and Ian for the good presentation. I think it's important to ask ourselves several questions regarding what are the challenges that we see related to the issue of methane. There's a huge disparity when you compare issues of methane production or livestock production of methane in Africa and in Europe. When you are listening to Dr. Mulat, the livestock that we keep mostly in Africa is mostly grass-fed and not to the scale that we see in Europe, where there are companies. I think I was looking at some statistics about 5 multinational corporations or meat companies contribute to about 80% of the European Union's entire methane footprint. In Africa, you find mostly it's farmers who are keeping maybe 1 cow in the smaller portions of land, mostly for milk and once in a while meat production. But also when you go to the drier parts of the country, like I saw a slide of Isiolo, there are farmers or pastoralists that depend entirely on livestock keeping, and that is their source of livelihood. And those particular lands are quite dry and quite suited for pasture and animal keeping of livestock. But even then, the methane production from those animals, from research that I've seen in Africa, is very minimal. Now, maybe you can see some certain shifts, like in countries like Kenya, where you're seeing a push for agribusiness or intensive agriculture, where farmers are being a lot of the green revolution pushes are showing that are pushing for farmers to produce intensely, like what you see what's happening in Europe. And that's one key concern. But sometimes you need to ask yourself, how do you create a balance between nutrition and the issues of methane production? Yes, we have a global problem with the issue of greenhouse gases, and methane being one of the key gases that is impacting a lot on the challenges that we are seeing with increasing temperatures and floods. We see that also in Africa. But sometimes it's good to try and create a balance, because there's a lot of nutrition deficiency in Africa. But some arguments that are given out there when you read at some of the researches or studies is that Africa needs more meat, we need more milk for better nutrition. Yet we are trying to move towards this system where we're saying, okay, we need to reduce. I think it's important the West and Europe and the Americans take up the mantle and look at the industrial production of methane, especially in those with the meat companies, because in Africa, at the end of the day, we really need to improve on our nutrition. So that balance needs to be, we need to do that balance. You've seen, like previously on the issue of the carbon markets, it's still going on, but when you look at the benefits going to the farmers who have been contracted in some of these huge projects for carbon sequestration, even the monetary gains from them have been very minimal. And so sometimes you need to see how to create that balance to ensure that we don't move towards techno fixes and solutions that at the end of the day might impact negatively on communities and pastoralists and even the consumers in Africa who need the meat. But also, one thing that I need to mention, if you look at some of the trade agreements or negotiations going on, in Kenya recently signed an FTA with the European Union. For a long time, the negotiations were between the AU, but now you're seeing a situation where the European Union is going into these bilateral agreements. There's also some negotiations that maybe have stalled now, but between the Kenya and the US, a lot of we see a big push for the multinationals to access the African markets. And so is it an issue of producing more there and exporting to Africa? What will be the nutritional value? And so it's important that we look at this trade. Is there, like when you look at the discussion, for example, on genetically engineered crops, and we also have the push towards the animals, is it about the multinationals accessing the African market, which they have not been able to have so much? And so those are some of the things that we need to be quite aware about. Livestock, we need to move towards agroecology. When you talk about agroecology in terms of the livestock, we need to look at issues of where we're having systems. When Dr. Mulat was speaking, he spoke about the biofuels. When you talk about the biofuels, when you process this slurry coming from the animals or the manure, you have the slurry that is used in making the biofuels. It's also used to make some biofertilizers like, sorry, not biofuels, biofertilizers like some of the biofertilizers like bokashi, and even in the compost. And this can be very instrumental in the challenges that we're having in Africa related to access or nutrition in our soils, instead of going for expensive fertilizers that we have to import. And with the current global challenges, financial challenges, and the challenges in Russia, the price of the fertilizer has really gone up, and the profits that are being made are very high, but the company selling the fertilizers. And so we need in Africa to focus even on supporting biofertilizers that are going to support in agriculture. So in brief, the move towards agroecology will encompass biofertilizers, biopesticides, improvement of our soils, and having those systems or ecosystems that are able to support and regulate each other. Thank you, Shefali.
Thank you, Anne. Yeah, you've raised a lot of different and important interconnected issues, right? Trade deals and what kind of incentives are they creating in terms of finance and market access for what kind of things, and carbon markets, who are they benefiting? These are all issues that are linked, especially as we start to think about, methane offsets that are being created at the moment. Thank you. Now we turn to a different part of the world, which is Denmark. And I have the pleasure to introduce you to Ole Faergeman. He's the vice chair of Frie. You're going to have to excuse me, Ole. Frie, Bønder, Levende lands, FBLL. FBLL was founded in 2003. It's the Danish member of La Via Campesina, a peasant movement organization with members in over 80 countries around the world. FBLL it advocates for small and nature-friendly agriculture and works for closer relationships between rural and urban communities to restore areas and nature. Now, Denmark is a very interesting case study, if I want to call it that. It has one of the most intensive pork production systems in the world, with its own problems related to groundwater contamination. It also has a vibrant dairy sector. Some very big global companies like Danish Crown, Arla, the dairy company. The argument is made that Denmark, with its efficiency, should export rather than cutting down production, so that more inefficient production in the global south does not replace this more efficient system. The Danish Council on Climate Change is recommending a carbon tax of 750 Danish krona per ton of CO2 equivalent on Danish agricultural emissions. Their recommendations suggest new and emerging technologies should be used, but that they should not slow down the long-term green transition and structural changes that are necessary for Denmark to meet its climate goals. What do you think about this, Ola? What kind of structural changes and solutions are needed for livestock production in Denmark to ensure a green transition and reduction in methane? You're on mute, Ola. You're gonna have to start over. You have 7 minutes, by the way.
Okay, 7 minutes. Okay. Thank you very much, Shefali, for inviting me. I really enjoyed the presentations and the comments from Monicah and Anne. It was a little bit difficult to understand Monicah. Denmark is a small country, you know, it's 6 million people, and it represents Northern Europe. You know, you really should appreciate that Europe is somewhat heterogeneous. There's a lot more pastoralism in Southern Europe than there is in Northern Europe. But Denmark has an extremely intensive both dairy, meat, and pork production systems. Danish pork system produces about 32 million pigs a year for slaughter. Accounts for an enormous amount of greenhouse gas emissions. The way that it's counted in our country is really very pertinent to what we've been discussing here, because of course methane is counted according to the 100-year scenario, which underestimates methane significantly. The Danish Climate Council that you mentioned, Shefali, is very aware of all of this and has suggested, as you say, that a carbon tax, a carbon dioxide equivalent tax should be introduced, 750 kroner per ton of carbon dioxide equivalents. But it also has a number of other suggestions, and especially it mentions the reduction of livestock production. I mentioned the pig production figures, 32 million pigs a year. The Danish dairy sector is really pretty large, 1.5 million cattle in this small country. And this system dominates the political discourse. Denmark has largely lost the battle for small-time farmers. In mid-20th century, there were 250,000 independent farms in my country. Now the number is 7,000. And the agricultural land has not been reduced that much. So the result is enormous consolidation of land use. My own view of this is, and this is really very pertinent to, or it can be very informed. I'm very happy with the what Ian and Daniel talked about, because my own view, and it's not the view of Danish farmers, my own view is that we really need to reduce livestock production by a very significant amount, at least by 50%, at the very least by 50%. If we're going to make any dent on greenhouse gas emissions from agriculture. The government of Denmark takes a somewhat different view. Their view is that livestock production should be left unchanged, the same amount of livestock production as now, but with the emphasis instead on techno fixes like inhibition of the enzyme that catalyzes the conversion of carbon dioxide to methane in ruminant animals. This is a drug. Essentially, they want to drug the cattle to reduce methane emissions. There are other measures also of techno-fix kind. There are other measures that have to do with the re-watering of low-level agricultural lands to create wetlands again. That's another measure that you cannot call a techno-fix, but which also could be important. I think the exercise that is needed in our country is to encourage, once again, encourage small-scale farming, and to do that in a way that that incorporates a reduction in the number of livestock and more emphasis on plant-based foods. I think I should stop here, Shefali, and open the discussion, I guess, for more questions from the audience.
Thank you, Ola. Appreciate it. It's a very different part of the world with very different population and land dynamics than what we've been talking about in sub-Saharan Africa. I'm gonna now open up the floor for questions. As I've mentioned, I know there's quite a bit of conversation happening in the chat, but if you'd like a question to be posed, please post it in the Q&A. There's a quick Q&A tab below. I think I will start with one by Ian Pluis. Sorry if I'm mispronouncing your name. He says the UK National Farmers Union exploits the two measures of GWP. That's the global warming potential. So that was one of the slides that Ian showed. There was the global warming potential of 100. Ola is talking about, the fact that actually what we're talking about right now with the climate emergency is really global warming potential of 20 years, because it's in these next 10 years where methane needs to really come down. And then there's the GWP star, which muddies the water. It says, well, look, it's a short-lived, and this is biogenic methane. It should be treated differently, and to justify a business as usual model. There are good scientific reasons for both measures, but might they lead to unfortunate consequences? So I'm gonna pose that question because it's a question that we think about it as well at IATP, because it's, again, luxury emissions versus survival emissions. When you're applying GWP star to a factory farm system of millions of pigs versus GWP star for sub-Saharan rangeland, how do we deal with that? And I don't know, maybe Ian and Daniel, you want to weigh in on this? And of course, any of the speakers, if you'd like to. Oh, I see Ola's already raising his hand. So maybe Ola, you start.
And I retract my hand. I had another question, Stefan. I think you should stick to the topic we're discussing now.
Okay. Do you want to? Okay. Maybe you can. I'll give you a chance to post the question, or.
Yeah, my question, Shefali, was really to Ian and also to Daniel, I guess. I was really fascinated by Ian's discussion about pastoralism and the emissions coming from pastoral livestock raising versus the industrial system. And I was wondering, maybe you said this, you probably did, but I didn't catch it, I guess. What are the mechanisms that explain that perhaps greenhouse gas emissions from cows in the pastoral system are somewhat less than you see in industrial systems?
Daniel, Ian, you seem like you want to come in. Maybe.
Well, I can, but Daniel, you should come in as well, because I think a lot of that work that Daniel mentioned from Mazingira has been very important on this. So actual real measures of livestock in the field versus these huge great animals that are put in respiration chambers that create these emission factor statistics that are then pumped into these generic models. I mean, they're quite different. They're very different animals. They eat differently, they selectively feed on different sources of forage, which may actually reduce methane. And they have, a different size. I mean, that's per animal output. The difference between comparing industrial systems and pastoral systems is my point about taking a systems approach. Now, if you're looking at the industrial system, you've got to include the sunk infrastructure. You've got to include the transport. You've got to include the use of all the feed and the fertilizer and all of that. It's not a sensible comparison just to say, here's an animal sitting in an industrially contained unit, and it's producing less methane per animal per hour than one that's eating rough forage. That's just not a reasonable comparison. You've got to take a systems view. And the systems view shows that we see a whole array of different activities within pastoral systems that reduce the amount of overall emissions. This can include forms of sequestration. As somebody said in the chat, I think there's a limit to sequestration. It's not necessarily all storage, but incorporation of manure, the distribution of manure in very different ways has a whole set of very different consequences for the dynamics of emissions, not only for methane, but also for carbon dioxide and nitrous oxide. So we're talking about very different systems here. And that's why you've got to compare. You can't do apples and pear comparisons. You've got to have a proper comparison. And we get stuck with these simplistic analyses, which are then aggregated up and used in these iconic figures that then become the basis for international policy and indeed campaign groups, and indeed use by the likes of the National Farmers Union in the UK. We've got to interrogate this data. And that's why it's so important that the work of Mazingira and others produces more data so that the interrogation can be more effective. These statistics are political. Let's face it, this isn't, science is never completely neutral. It's situated within a debate. Let's be clear about that. And that's why I think, bringing questions of justice into this debate, the relationship between science and politics and justice, and this old idea about luxury and survival emissions, they're not equivalent. We've got to have a different view. And this is why, in relation to some of the other comments made in the Q&A and in the chat, those simplistic figures that came out of that science article are they're just too limited. They're based on a limited slice of data, perfectly legitimate for that bit of data, but let's not extrapolate them to the whole world. Let's ask which livestock where. And I agree entirely with Daniel that we need more research and more understanding of what's happening in different types of rangeland systems.
Daniel, do you want to come in? And maybe I would just add, given what Ian has just said, you're comparing apples and oranges. Your chart that looks at no graze, extensive and mixed is the middle category. Is it comparing apples and oranges? What's that data doing? And maybe also responding to this, yeah.
Yeah, I think, thank you very much. And I think Ian has answered most of it. And yeah, it's very important to look at what are the systems in Africa and what are the systems in global north. So we know the African systems have limited with the input and production is very low. And we know the farmers are really dependent on their livestock for income generation, for nutrition, for a lot of things. So I think it's very, very important to look from that context. So, I mean, what I see for African system is definitely there is room for improving the productivity within the system without switching from, the pastoralist to intensive system like the north, because as I've shown in one of the graph and the variation of the milk productivity within each system itself is very wide. So that means if we support farmers with proper financing mechanisms, incentive, trainings, and awareness raising, there is a lot of opportunity to improve the productivity so that we can reduce the emission intensity as well. And Monicah has already talked bringing back nutrient back to the farm, and all those kind of practices has really have a great role in supporting the system. So I think, of course, we do have some few data, and those clearly showed that our system is not as meeting as the global north. But of course, we also need more data. We need to do capacity for researchers, students, and government officials to generate those robust and local data so that we can inform, practices, what practices is better for both reducing emission and then at the same time also increasing the resilience of the system to climate change. Because, probably you have seen in the recent news that because of recurrent drought, a lot of animals have been dying in Africa. So, those farmers are dependent to those animals. So, it's not about only greenhouse gas emission. It's also like increasing the resilience of the system so that the farmers support themselves and also contribute to sustainable management of the pastoralist rangeland system. For example, if you see the rangeland system, we have been doing some research right now looking at rangeland for livestock production and then also switching the rangeland for a crop production. So, there is a preliminary result which clearly showed that when you have a rangeland for a crop production and for a livestock production, the amount of organic carbon you sequester in the system is higher than when you turn that rangeland into crop production. So there's clear evidence that it's not only about emission from the animal itself, and also it's also contributing to sequestering organic carbon into the rangeland. So I think we should look at from this perspective, and I think Ian has already said a lot on that, and yeah, I will leave it at that.
Thank you. I think, Monicah, you had briefly raised your hand. Did you want to weigh in on something, or should I move on to another question? We don't hear you. Maybe while she gets it, did any of you want to comment on the GWP star versus GWP? Or I guess in some ways you already did, Ian, right? Because you're saying you're comparing apples and oranges, and actually you need to look systemically, and that's what matters most. That if you're just honing in on methane, then you're missing all the other gases. I think there was also a question here that said, are you guys also looking at N2O? And I think that's kind of getting at the same thing. There's also somebody who's saying, I'm interested in the recurring issue of justice and responsibility. Ian Scoones framed it through epistemic and distributional justice, global North domination, and Maina related to the global South nutrition crisis set against the North's disproportionate responsibility for GHG emissions. What both of these require is funding for research driven by the global South and Indigenous peasant communities. How do we link these justice issues to ensure localized research into livestock sovereignty? And I think maybe I would just add, there was a slide that you presented, Daniel, which was looking at adaptation and it was looking at mitigation. And you talked about, then there was another graph that you showed, which was saying, if you use 5 climate smart practices. And I think for me, the issue is, what do you mean by that? Because climate smart is a big buzzword. It's a big policy catchword that is being used by the industry. It's being used by governments. It's also being protested against by a lot of people who are pushing for agroecology, because climate smart can just mean fertilizer use, but just use, synthetic fertilizer use, but use more efficiently. So when you're saying these people are adapting to climate smart practices, what are you actually talking about? What kind of practices are the ones that are actually delivering the kinds of results that you are seeing in these different systems? Could you elaborate on that a bit?
Yeah, definitely. That's a big word, climate smart practices. The promise is to improve animal productivity and also increasing resilience to climate change and reducing greenhouse gas emission. That's a promise. Yeah? So, climate smart practices are different for different systems. So, within this project, the project which was implemented by government of Kenya with the support of World Bank, they have identified different practices. For example, with regard to forage, they have looked at improved forage, for example, which has high quality and then also provide more forage to the animals. And they also looked at, for example, manure management. For example, in a manure, it's very important to cover the manure so that you can reduce emissions and at the same time nutrient losses. So those are like manure management practices. And they also looked at, for example, biodigester, where you put manure into biodigester, you recover energy in the form of biogas for a cooking, and that also replaces fuel wood use, means reducing deforestation. And then also at the same time, you're producing bioslurry, which is very rich in nutrient. You can put it on a forage plot or in a crop plot for crop and forage production. Yeah. And they also looked at another practices, for example, the health of animals, improving the health of animals, and some breeding practices which improve productivity, but it's also important to increase the resilience of the animals to, for example, heat stress, because we know that the warming of it's also important to look at that. So, I mean, they have those range of practices, and what they have looked at is like, okay, when these practices have adopted by the farmers, it could be 2 of them, it could be 3 of them, and 5 of them. So for all those practices, I mean, those practices are not meant only to reduce greenhouse gas emission, because they are also, let's say, for example, manure management. There you're bringing back a nutrient to the soil so that, you know, you're increasing the manure fertilizer value and also the resilience of the soil, because when the soil is rich with the nutrient and carbons, it also makes it resilient to climate change as well. So when they looked at those practices and when we collect the data, what we have found that in all those farmers who adopted one or more of the practices, they have increased their milk productivity, especially for the extensive system. Yeah? And then it also reduces the emission intensity. That means emission per product, which is in this case is a milk. Yeah? But then the major challenge with the farmer was the costs of introducing these practices is very high. But when you factor in the milk gain, the additional milk gain because of the introduction of these practices, the cost is much lower than when you don't adopt those practices. So, I mean, that clearly showed that this kind of climate smart practices, those practices I've just told you, are important for these farming systems, but the costs are very high. So that's why we need to bring in, you know, tailored financing mechanism so that we can reduce the upfront cost. It could be through carbon finance or through social impact financing, where you provide those practices. I mean, you provide money to the farmers so that they can adopt those practices. So I think that's what what was implemented through this project. But of course, we need more data on similar projects that have been implemented across Africa, just to find out that which climate smart practices are working for which system. Yeah, I mean, all of them definitely they don't lead to the outcome you are expecting, but we really have to see from a system perspective. I hope that answered your question.
There are some very specific questions in the chat about references and about, so I encourage the speakers and the panelists to maybe look at them and see if you can type some of them. One of the questions that I wanted to raise before I raised the question about why is there so much extensive, why is it so hard to get attention for extensive? I'll come to that because I think there's been a lot of chat on that issue, but also I wanted to I cut you off on the biodigester slide. And so what we're seeing in the global north is massive partnerships between massive factory farms in Iowa, in Denmark, with fossil fuel companies, because you've got large amounts of manure, which wouldn't be there if you didn't, and N2O and everything else that Ian's talking about. And then you've got these partnerships with big oil. So you've got big livestock, big oil. And you were being funded to, say, trap this manure in a biogas digester system in sub-Saharan Africa. Can you talk a little bit about why that system is different than what is happening in the global north right now? Because what we're seeing is a big trend for taking pollutants, actually incentivizing the scaling of big livestock, right? Because if you get another monetary value out of the system, then the system is perpetuated. It's not actually transitioning. So how does that apply within the systems that you're working on with biogas digesters? Is that a system that is, where is that leading to? What does that look like? Is it radically different? I imagine it is, but maybe you can elaborate a little bit.
Yeah, I think that's a very good question. So, I mean, if you see the biodigester sector in Africa, it's mostly dominated by this small-scale biodigester, which is used by smallholders having 4 or more cattle for feeding the biodigesters. And of course, in the global north, that of course, that's a big biodigester manure from thousands of animals and producing such a huge amount of gas, maybe to substitute fossil fuels. And but I think the African system is quite different. I mean, through this ABC project, what they have been trying to implement is to install those small biodigesters, because with the biodigester, you're producing the gas, and then at the same time, you're using it as a source of cooking fuel and also for lighting. So if you look at the smallholder farmers in Africa, most of them, they are still more than 95% is still dependent on fuel wood for a cooking purpose, and they don't have lighting. Yeah, so this is definitely contributing in reducing the use of fuel wood. So that's expected to reduce deforestation. And then at the same time, if you see in African system, it's the women who mostly go to the forest to collect the wood. Yeah, so spend 5 or 6 hours for collecting fuel wood. So when they replace biogas with a fuel wood, that means they will have more time to spend. It could be on their agriculture, or it could be using their time, for example, for the children as well, on their education or other productivities activities. So I think the context is quite different when you look at here and then the global north. So in that way, biogas is, I mean, for farmers, it's not seen as for reducing greenhouse gas emission, although it can reduce greenhouse gas emission. I mean, those small biodigesters, they can reduce at least 4 to 5 tons of CO2 equivalent per year. Of course, they can reduce green, but for a farmer, the most important to get energy source, to get fertilizer they can put in their farm, because you know the price of fertilizer has skyrocketed. It's very expensive. They cannot afford to buy fertilizers, and they can use this one for returning nutrient to the soil. And then, of course, for a woman, in terms of empowerment is important. And then the other thing is also highly linked with indoor air pollution. So whenever you use, for example, fuel wood, because of the smoke, because of carbon monoxide, because of all those pollutants, there are, I mean, if you look at the WHO reports, there are more than 3 million people die because of indoor air pollution every year, because of the use of fuel wood. So when you replace fuel wood with this clean biogas cooking, and definitely it's also reducing indoor air pollution. And then another practices we currently coming up, for example, in Ethiopia and I think in Uganda as well, they also collect in their toilet to biodigester. So in that way, they're also improving sanitation. You know, I mean, if you look at the farm system, they used to use open defecation. Now they have a toilet. That toilet is connected to biodigester. The biodigester reducing the pathogen transmissions and all those things. So I think the systems are different. The benefits are really immense in Africa, but the financing is still very difficult because they are very expensive system to install. So if you don't have carbon market, if you don't have any financing system which can help farmers to pay in a longer term, it would be difficult to adopt these practices. Thank you.
Interesting. That's a whole other debate about what we're incentivizing with carbon offsets. But that's for another webinar. We unfortunately have to wrap up. As I said, you know, if your question hasn't been answered, we do have the questions. Speakers can also submit their questions directly into the Q&A, and we can see if there's some questions that have not been answered. Maybe we can send replies. I would love to start. I don't know if Monicah can speak. I would love for each of the speakers to give maybe one or two concluding remarks based on this conversation that we've had. Monicah, are you able to speak? If not, we will print your remarks, I'm being told. You will share your comments with us after the webinar, but maybe you try once. Oh yeah, okay. I'm sorry to not have you be able to actually speak in there, but Anne, do you want to start?
Yeah, just quickly, and thank you to all the presenters and the interesting discussions. I've learned quite a lot, but I think one of the things that maybe we might need to put investment in, and it's good that Mazingira is here and Ian, is look at agroecology. There's a big move towards agroecology. In fact, in countries like Kenya, there is the development of a national agroecology strategy. Uganda, I think, is way ahead. And I think Togo. How do we look at agroecology and do a study on looking at agroecology and how it supports biofertilizers and the reduction of emissions, greenhouse emissions, particularly methane. And that would be very good in terms of justifying and pushing for more funding going to agroecology. That would be my clarion call. And of course, the researchers are here and something that we can look at how to support that kind of research. Thank you.
I also see a message from Monicah saying more research and support for agroecology for food system transitioning. Ian, Ola, do you want to say something? And then Ian?
I've been really happy to participate in this discussion. I think I've learned even more than Anne has. I don't think that Africa should emulate Northern Europe. There's a huge biogas system in place in Denmark. The biggest of these systems is Nature Energy, which has just been bought by Shell fossil fuel company. And we have had an estimate of the damages to lakes and streams and the seas around Denmark. It'll take at least 100 years to reestablish natural conditions in the seas around Denmark, even if we stopped the huge emissions of pollutants and gases from, for example, the pork industry. So do not emulate Denmark.
Thanks, Ola. Ian.
Thank you, and great discussion and very good comments in the chat that I encourage everyone to have a look at. I think, you know, I just want to reiterate that basic point that I made. We just have to get the debate more sophisticated, lumping everything together, that somehow all livestock systems are the same, is just doesn't work. we need more data, we need more effective analysis, but we shouldn't just take these global aggregate figures from these big models that just extrapolate up from a particular industrial type system and assume that covers all livestock everywhere. There are lots of livestock systems, including pastoralism, which we've discussed, but many other livestock systems where there's not much alternative on that land for other productive uses, where they produce high quality food of high nutritional value, and that the environmental impacts are considerably less at a systems level than industrial systems. So whether we call that agroecology or not, I mean, focusing on those type of systems, by all means, improving their efficiency, by all means, using whether it's seaweed or daffodils or whatever to reduce methane, let's focus on those systems, because those are where the vast majority of people around the world who make use of livestock and make use of extensive rangelands make their living. And if we get all of this distorted by all livestock everywhere are bad, then we're going to cause all the type of injustices that I talked about. And that's why we've got very frustrated by the way that this climate and livestock debate has gone. And it's very good to have a more nuanced discussion in this webinar.
Thank you. Daniel, last word?
Yeah, thank you very much for this opportunity. And I think it has been a great discussions from the panelists. And then also I can see a lot of questions and then the chat as well. That has been very great. And I think what I would like to say, the African livestock system is quite different from others, and the needs for the farmers, the governments are different. We really have to support the livestock system to make sure it can improve animal productivity. At the same time, also looks co-benefit in reducing greenhouse gas emissions and increasing the resilience to climate change. But for that, we need more research, more data, collaboration, not only locally, globally. Thank you.
Thank you all so much. This has been a challenging webinar to organize. We've had different academics, different perspectives. The lineup has changed over the coming weeks, and but it's been such a fantastic set of speakers and perspectives that we've had today. You know, we need so many more of these kinds of discussions, and I feel like the chat itself is an entire webinar that is happening in parallel, and so we'll be happy to share the chats. For me, yes, I think the big takeaways really what stand out to me is this whole concept of fair share. I see a long intervention by Paul, who's talking about, you know, where it needs to be. I think that's something that Ian has echoed, where, for what purpose. And I think what struck me really is the slide from Daniel, which said, look, we are not tracking adaptation in livestock. There is no data. So right now you have research funding for a very mitigation productivity perspective, but for climate resilience and adaptation, I'm not seeing a whole lot of data and research to really examine which kinds of practices are going to create climate resilience, which kind of practices are going to allow adaptation, what kind of adaptation is needed as sub-Saharan Africa is hit by a massive climate crisis in the coming years. It seems to be an essential thing because there are completely different systems with very different, you know, you've got 35 million pigs and 6 million people, Ola, in Denmark, and then you've got, you know, a very different system in sub-Saharan Africa and in different places in the global south. So, you know, our attempt was to really broaden this conversation, because currently in policy circles, at the climate change conferences, in high-level conferences where the livestock industry is very present, we are not having these conversations, and we need to have many more of these conversations to really understand what kind of solutions do we need for methane, where, and what matters in terms of just the overall picture for climate resilience and mitigation for methane, which is urgently needed. So I thank you all for your time, and thank you all the participants who stayed with us through all of this time, and we'll be sending you the recording for this in the presentations. Thank you very much.